Hallie Swanson, and today we'll be learning lesson 5.3, the properties of definite integrals. We'll be working with the properties of definite integrals to help us understand better the derivative integral. Connecting derivatives and definite integrals sets the stage for the fundamental theorem of calculus. The first rule is the order of integration. That says that the integral from b to a of f of x dx is equal to the negative integral a to b f of x dx. Rule number 2 is the zero rule. The integral from a to a f of x dx equals 0. Rule number 3, the constant multiple rule, is integral from a to b k f of x dx equals k a to b f of x dx. That means you can take the k out and put it in front. If k equals -1, so shown here with the negative, you can take the negative out. Rule number 4 is the sum and difference rule, stating that an integral from a to b f of x plus or minus g of x dx is equal to the integral from a to b of f of x dx plus or minus the integral of a to b g of x dx. Rule number 5, additivity, states that the integral from a to b f of x dx plus the integral from b to c f of x dx is equal to the integral from a to c of f of x dx. Rule number 6, the max-min inequality rule. If max f and min f are the maximum and minimum values of f on the interval from a to b, then minimum f times b minus a is less than or equal to the integral from a to b f of x dx, which is less than or equal to the max f times b minus a. Finally, rule number 7, domination. F of x is greater than or equal to g of x on the interval from a to b. Therefore, the integral a to b f of x dx is greater than or equal to the integral a to b g of x dx. Also, f of x is greater than or equal to 0 on the interval from a to b. Therefore, the integral a to b f of x dx is greater than or equal to 0. Using the rules for definite integrals, suppose that the integral from 1 to 4 f of x dx equals -2, and the integral from -1 to 1 f of x dx equals 5. Now we'll find the integral from 4 to 1 f of x dx. So, you flip it, negative integral 1 to 4 f of x dx equals -2, which equals 2. Now it's your turn to find the integral from -1 to 4 of f of x dx. Don't forget your givens. Pause the video now. Now your answer, the integral from -1 to 4 f of x dx is -1 to 1 f of x dx plus 1 to 4 f of x dx. That is 5 plus -2 equals 3. Good job.
Okay, what was that? I couldn't.
Integral of 0 Now we're going to talk about finding bounds of an integral, showing that the value of the integral from 0 to 1 square root 1 plus cosine of x dx is less than 3 over 2. The max-min equality for definite integrals says that min f times b minus a is a lower bound for the value of the integral from a to b f of x dx, that is max f times b minus a, is an upper bound. The maximum value of 1 plus cosine, the square root of 1 plus cosine x on the interval from 0 to 1 is -2. So the integral from 0 to 1 square root of 1 plus cosine x dx is less than or equal to square root of 2 times 1 minus 0, which equals the square root of 2. So the square root of 2 is about 1.414, which is less than 3 over 2.
How you doing? Yeah, nice job. You went 2 for 3 or something?
Now we have a definition which you need to make sure to copy into your notes. The average mean value. If f is integrable on the interval a to b, its average mean value on a to b is a of f equals 1 over b minus a times the integral a to b f of x dx. We'll now apply this definition to find the average value of f of x equals 4 minus x squared on the interval 0 to 3. Average f equals 1 over b minus a integral a to b f of x dx, which can be worked out as shown to equal 1. When 4 minus x squared equals 1, or x equals plus or minus 3, this function assumes its average value, since x equals the square root of 3, lies in the interval 0 to 3. In fact, a continuous function on a closed interval always assumes its average value at least once in the interval. This is known as the mean value theorem for definite integrals. If f is continuous on the interval a to b, then at some point in a to b, f of c equals 1 over b minus a times the integral a to b f of x dx. Our final lesson covers finding an integral using antiderivatives. We will find the integral from 0 to pi of sine of x dx using the formula integral a to x f of x dt equals f of x minus f of a. Since sine x is the rate of change of the quantity f of x equals negative cosine x, or f prime x equals sine x, then the integral 0 to pi sine x dx equals negative cosine pi minus negative cosine 0, which equals negative 1 minus negative 1, or 2. Now it's your turn. Find the integral from 0 to pi over 2 of cosine x dx. Pause the video. Alright, here's your problem up here. 0, integral. Here was your problem up here, and again, the integral from 0 to pi over 2 cosine x dx equals sine pi over 2 minus sine 0. That is 1 minus 0, which equals 1. Woohoo! Good job, you finished!
Hi, I'm Derek Crane, and today we're going to do chapter 5.3 about definite integrals and antiderivatives. We're going to study 4 concepts: properties of definite integrals, average value of a function, mean value for definite integrals, and finding integrals using antiderivatives. Okay, so first we got to learn the rules for definite integrals. Okay, and the first rule is order of integration. An order of integration is that on an integral from b to a, f of x dx will equal negative from a to b f of x dx. Okay, so the second rule is the zero rule, and it states that if you go from a to a, then it'll be 0, which makes sense because you're not going anywhere. Okay, so the third rule is the constant multiple rule. This means that from the integral a to b of a constant times f of x dx is equal to a constant times the integral from a to b f of x dx. And it also means that the integral from a to b of negative f of x dx equals negative the integral from a to b f of x dx. So this rule means that you can pull out the k and you can pull out the negative if you need to. Okay, rule number 4 is the sum and difference rule, and that means that on an integral from a to b of f of x plus g of x dx is equal to the integral from a to b of f of x dx plus or minus the integral from a to b g of x dx. That's rule number 5 is the additivity rule, and that means that from a to b f of x dx plus b to c f of x dx is equal to a to c f of x dx. Okay, rule number 6 is the max-min inequality rule. If max f and min f are the maximum and minimum values of f on an interval from a to b, then min f times b minus a is less than or equal to the integral from a to b f of x dx, which is less than or equal to max f times b minus a. Okay, so rule number 7 is the domination rule, which means that f of x is greater than or equal to g of x on the interval from a to b. Therefore, on the interval from a to b of f of x dx is greater than or equal to the integral from a to b of g of x dx, and f of x is greater than or equal to 0 on the interval from a to b. Therefore, on the integral a to b, f of x dx is greater than or equal to 0, g equals 0. So now we're going to put those rules that we just learned into action. Okay? So in this problem, the integral is from 1 to 4, and f of x dx equals -2. And then if we make this negative and go from 1 to 4, then f of x dx equals -2, which equals 2. Okay, so now we're going to do a homework problem. Given these functions, find this answer. Please pause the video. Alright, I know that problem was pretty difficult, but let's see if you got the right answer. The answer is 5 plus -2 equals 3. Good job. Okay, so next we're going to learn about the average mean value. The definition of which is if f is integrable on the interval from a to b, its average mean value on the interval from a to b is 1 over b minus a times the integral from a to b of f of x dx. Alright, so now we're going to find the average value of the function f of x equals 4 minus x squared on the interval 0 to 3. So the average is 1 over b minus a times the integral from a to b of f of x dx. So if you plug in all the numbers, you'll get 1 over 3 minus 0 times from 0 to 3, 4 minus x squared dx. And then when you simplify that out, you get 1 over 3 minus 0 times 3, which equals 1. Okay, so I wrote a bunch of words up here for you guys that are about the mean value theorem, and now I'm going to read them to you. To go along with the average mean value theorem, we can assume that when the function is continuous on a closed interval, it will assume its average value at least once on the interval. This is known as the mean value theorem for definite integrals. The book says if f is continuous on the interval from a to b, then at some point c from a to b, f of c will equal 1 over b minus a times the integral from a to b of f of x dx. Okay, our final section of this lesson covers finding an integral using antiderivatives. We will find the integral from 0 to pi of sine x dx using the formula from a to x f of t dt equals f of x minus f of a. Since sine x is the rate of change of the quantity f of x equals negative cosine x, or f prime x equals sine of x, then from 0 to pi sine of x dx equals negative cosine pi minus negative cosine 0, which can be simplified down to negative 1 minus negative 1, which is 2. Okay, so for our final homework problem, I'm going to have you guys find the answer, find the integral from 0 to pi over 2 of cosine x dx. Okay, so the answer is the cosine changes to sine, and it's sine of pi over 2 minus sine of 0, which simplifies down to 1 minus 0, which equals 1.